So hello everybody, my name is Vince Puglia. I am a developer advocate for Dialogic, and I promise this is not going to be a product pitch or a company pitch, but although I do have this Dialogic brand on here, I just want to let everybody know that I'm going to be talking about what we've learned over the years and product best known methods of what we learned from a service provider and from an enterprise perspective, being able to implement media servers and server-side media into a WebRTC network. So don't be afraid of this big, large slide here, but I do have to put that disclaimer in there. So my role and my charter at Dialogic is to be a developer advocate for WebRTC, but also bringing to light the advantages of using WebRTC with the server-side media. So that's what I'm going to be talking about today, and that's hopefully what I'll be able to get across in this presentation. So the topic I have today is a large topic. It's miles wide and miles deep, so I do have to narrow the scope here a little bit. So what I'm going to be discussing today is media, and specifically scaling media using a media server. But what we won't be talking about, and what is still equally important for scaling your application, is things like signaling, user identification, access control, notifications, federation, and just a ton of other things that go into scaling your application. So although I would love to talk about other things, we'll focus strictly on scaling media. So that said, it's just quickly a show of hands. How many people are aware of what a media server is? And maybe some of you, all right, good, very good. So my definition of a media server is quite simple. It's a network element that's deployable in an enterprise customer premise, a service provider IMS cloud, or a specific cloud, a private cloud, for the processing and manipulation of media. And what is media? So it's video, audio, or data. So considering all of you are pretty familiar with what a media server is, I won't go into too much detail. So just to level set a bit, I wanted to talk about what is scaling. And I asked Google what is scaling, and I came across the most reliable source I know, which is Wikipedia. And everybody knows if it's on Wikipedia, it's pretty much got to be true. So the definition of scalability, according to Wikipedia, is the ability of a system, network, or process to handle a growing amount of work in a capable manner, or its ability to be enlarged to accommodate that growth. I like that definition. I think it's a pretty good definition, but I think I needed to tailor it a bit and modify it towards this conversation. So my definition, and I'll base it on this, is scalability is the ability of a real-time communication application to reliably handle a growing amount of feature-rich work in a capable manner, or its ability to be elastic to accommodate that growth. So I'm obviously highlighting three terms there: reliability, feature-rich, and elastic. So reliable, having a design for failure, planning for a catastrophic event, knowing when it's going to fail and having a plan to accommodate that. Feature-rich, being able to provide many options to a programmer, a developer, a network. And then finally, elastic, the ability not only to scale vertically, but also scale horizontally. And so the ability to do that programmatically rather than manually. So I'm going to use these three terms to frame up the conversation going forward. So we'll dig into each of these a little bit more as I progress. So why is scale important? And I guess why am I here to talk about scale? So I guess, to be honest and be simply put it, scale is kind of hard. And I don't want to minimize the scaling aspects of peer-to-peer of a normal WebRTC, but scaling a decentralized architecture is much different than scaling, say, a centralized architecture with a media server. So I don't want to, again, minimize the fact that decentralized is easy, but this is quite different. So before I get into a little bit more, what is peer-to-peer and what is peer-to-server? And I'm all for peer-to-peer. It's great. I think it's fantastic, but it does have its limitations, specifically around use cases where you want to add some services. So specifically, recording. What happens when you want to record? And in this case, I have the example of recording your child's soccer game, but maybe something more specific would be around recording, say, a contact center. So being able to apply quality of service for your contact center, making sure that they're getting the right quality of service. Broadcasting, so breaking that 1-to-1 ratio and breaking it into one-to-many. So being able to scale your CEO's conversation or your CEO's all-hands meeting to 10, 100, maybe 1,000 employees. So being able to do one-to-many is where maybe a peer-to-peer model doesn't fit in. Transcoding. So on the panel earlier, we were talking about the fact of having multiple media stacks. Well, I think that having a myopic frame of mind or a myopic point of view where there's going to be only a few stacks is quite limiting. So having the ability to not only transcode between VP8 and H.264, but also be able to talk to multiple VP8 stacks. Augmented reality. So the example I have here is being able to take a live feed and apply some type of image overlay. And maybe this is a bit advanced, but being able to do things like text overlay, image overlay, things like that that'll apply to not only the web, but telephony as well. Stream processing, and the example here I have is being able to do automatic speech rec and also text-to-speech, but also being able to do digit detection, being able to do IVRs and be able to detect what a user inputs. And then finally, multi-party conference. And I'm going to get into this a little bit more and talk a little bit about how a media server can benefit this, but being able to break that peer-to-peer mesh model and going into a more centralized point of view of having every conference or every participant in the conference come into a centralized service. So with that, before I get into that use case, I just want to give a quick example of what a peer-to-peer versus a peer-to-server looks like. And on the left-hand side is your typical WebRTC peer-to-peer. So up at the top, you have your signaling server. The signaling from the clients is all going from the clients up to the server, and then media streams directly from client to client. So the peer-to-server model is just slightly different. Again, we have the signaling server. The clients, again, put the signaling up to the signaling server. But instead of the media going direct, it is going to a centralized media server. And you'll also notice that I do have a control leg coming down from the server, and that is for issuing commands to the media server. And I'll actually be touching on that a little bit more in a future slide, so just to mark that in your memory. So first, to talk about the few different models, and this was covered a few minutes ago in the previous conversation, but peer-to-peer mesh, and I think peer-to-peer has its place, and it's great, but what happens when you start to expand that peer-to-peer into peer-to-many? So in this model, every participant in the conference needs to send their stream to everyone else, and then vice versa. They have to receive their stream in return. So while this is effective for a few clients, once we start to scale this to 10s, maybe 20s, it starts to fall apart. So you'll notice down here on the left-hand side, I do have some parameters that we need to work within for making this a scalable and effective solution. So first of all, encodes cost more than decodes. What we found is encoding typically costs about 4 times as much as decodes. So that's a parameter we need to work within to make this model work a bit better. Second point is uplink bandwidth typically is limited. So if you think of your home network or your corporate network, typically the uplink is far less than the downlink. And then finally, the client processing is not unlimited, and this is especially true with mobile. So as we move from clients to mobile devices, you are quite limited in what the processing can do on that device. So again, these are just three parameters we're trying to work within, and like I said, the peer-to-peer model is great. It's a fantastic model. It's the lowest latency, but introducing things like a media server can effectively scale this better. So the first model I want to introduce is a selective forwarding unit or a routing unit, an SFU. So in this model, all the clients encode and send their stream to the media server. The media server then will take that media stream and then route it to all the other clients in the conference. So effectively, the uplink is 1, so your encode is 1, but you're also needing to decode all the streams from the conference. So while it does drastically reduce the amount of encoding and sending, you're still getting a lot of decodes that need to be processed. So it is a bit of a downlink issue. This is solved a bit with SFU with simulcast, and the high-level concept of simulcast is being able to encode multiple streams, one at a high bit rate and one at a low bit rate, and then at that point the SFU will then route based on the client's abilities, either the low bit rate or the high bit rate. So we are doubling the encodes, but the decodes can be helped with a lower bandwidth or the lower bit rates. So the last one I'll cover is an MCU model, a multi-point control unit. And in this model, it's one stream is sent from the client, and the media server that will then mix it and send it back to the other client. So this will drastically reduce the amount of encodes and decodes that a client can get, but it also introduces transcoding that, from a server perspective can be expensive. It also puts a bit of latency in there because there is transcoding going on, but it's a payoff, I guess. So if we start to boil this down and start to compare these three models and figure out where the differences and the commonalities come from. So we first take a look at server load, and in a mesh model, there is no server, so there's no load, so we'll mark that as NA. Second of all, the SFU, it doesn't transcode it, but it does route. So there is a bit of a server-side consumption there. The MCU is very high because it is transcoding every stream that comes in, and it also then needs to mix it and send it back out. So the MCU model is quite high there. Oops. So next is the client load, and in this case, because it is mesh, they're getting every stream. It's many to many. The client load on that case is high. The client load on an SFU, while it is encoding just one, it can receive every stream in the conference. So the medium, the processing there is medium, and then finally the MCU model, it is 1-to-1, so it remains pretty normal. And then lastly, the bandwidth, and this is where the chart above comes in, and it's a bit theoretical as clients start to grow from 10 to 100 sessions. The bandwidth in a mesh model does exponentially grow. But in an SFU model, it linearly grows, whereas in an MCU model, it'll remain relatively flat, 1-to-1. So what does this all mean, and where are we going with this? And I'm not here to advocate one model over another. I think they all have their merits. So where am I going? So basically, you need to make the decision of where you're trading this off. So where are you pushing the processing? Are you pushing it to the server, or are you pushing it to the client? And I think that there's important notes on both. So like I said before, the processing of the client based on who it is, whether it be a mobile or a PC, does need to come into play of where you're pushing the processing. So this is an important trade-off. Again, I'm not advocating one or another, but the decision is up to you as far as what model you'd like to go for. So the second note that I put up there was reliability. And I will say that reliability is in the eye of the beholder. So every conversation, and if I were to ask what is reliable to you guys, we would probably get a bunch of different answers. So I'm just saying that in this case that the reliability requirements of, say, an IVR or a voicemail system will be much different than, say, a mission critical application. So again, the way we'll look at it in this case is we're going to look at it from the spectrum of we want high reliability with very little interruption in service. So for something like that, we've come to adopt a process called media resource broker. And so what is a media resource broker? It's basically a standards compliant network element that actively polls the media servers, and it'll detect a failover and then switch the media from one media server to the other. So this is great, and it's great bullets, but what does this actually mean? And for me, it's about applying this to something that real life and playing with it. So what I did was I created an MRB that first put myself into a conference, and then I had two media servers, one hosting the media in a conference. I would pull that plug, and it would be switched over to the second media server. So you'll see there's no sound, so you'll have to take my word on this, that there is probably a 50 to 100 millisecond hit in audio, but the video essentially comes back in 1 to 2 seconds, and the video is reliant on the iframe coming in, so the service is restored based on when we get that coming in. So media resource broker, it does add the higher reliability to what we need for creating this scalable solution. And then the last note that I had was around scaling, and scaling is something that's I think it's a bit tricky. So basically we have the layers here of the application server, which holds the business logic, the MRB, which I just talked about in the middle, and then the media server at the bottom. So when you have just a few media resource, few sessions coming into a media server, it tends to be easy. But what happens when you get a lot of sessions coming into a media server? How do you start to scale this, not only vertically, but horizontally? So what this is basically is the ability of a orchestrator or a management interface to control when a media server can expand and contract. So in this case, the media server will send a call for help, or it'll send a usage help saying, I need a little help. The orchestrator will come in and say, all right, I hear you. And then it'll start to expand the ability of a media server. So basically what we're doing is we're turning one media server into the ability of a cluster. And then once that's done, because it's expensive to have those available, we can start to scale it back down. So the ability to elastically grow and elastically contract the network based on your needs. So again, like I said, turning one media server into an availability of multiple. So this is my last slide here, and it is a 2-minute scaling review of what I just said. So again, peer-to-peer is fantastic. I advocate it all day. But what happens when you start to get feature-rich capabilities into your network, and what happens when you start to get some load into your network and needing to scale? So first of all, we need to introduce an application server where the signaling will go, and then also introduce something like a media server to supply things like recording and conferencing. Next, the media resource broker can give us a level of reliability where we could start to pair the media servers up, so if something were to happen, we could start grouping them so that a failover can effectively happen. And then last, we could start clustering everything together and introduce an orchestration layer where everything is working in conjunction, and we can effectively get a feature-rich, reliable, elastic, scalable solution. And that's all I had.
Questions?
Questions?
I like this gentleman. His question saves me having to do any of the hard work here.
Just a question. In the context of scaling media servers, are you also able to scale conference rooms? And if so, how does that work, turning one conference room and spreading it across 2 machines?
Good question. So audio is easier to expand geographically than video, obviously. So what we could do is take a media server, say in California, and a media server in a data center in Virginia, and essentially make a central hub that those two talk to and combine. Video is a bit tougher. We are looking at ways we could bridge the media server together, but today it's a bit of a limitation.
Can't you, sorry. I mean, if you're doing active talker, can't you have one video conference talk to the other? The active talker comes live. I mean, I think we've actually done that with your media servers.
Yeah, absolutely. You absolutely could do that. And the only issue there is just latency. So yeah.
So you didn't mention anything about Peer Content Delivery Network. What's your, I know you guys are in a business of selling servers. What's your thoughts on that?
So we typically stick to what we know best, and our media has been around real-time media and scaling that. So I don't know if I have an opinion on that.
I assume that sounds like you don't have an opinion.
I don't, unfortunately, sorry. Anything else?
Okay. Thank you once again, Vince.